Go.
Hi, and welcome to this third discussion on dexamethasone, which has the molecular formula C22H29FO5. In today's discussion, we'll be talking about the intermolecular forces in bonding of dexamethasone, which had not been mentioned last week, as well as the acidity and basicity of the compound and its common uses. So let's get started. So, when we're looking at the intermolecular forces and bonding forces of dexamethasone, the ones that easily stick out are actually seen on the alcohol components. So, we see that we have oxygen to hydrogen bonding on each alcohol, and oxygen binding to hydrogen is the very definition of hydrogen bonding. So, we have hydrogen bonding present here. And for the sake of time, I'm only going to write it on one alcohol, but it is present on each of the three alcohols. Our next intermolecular forces that are present here are actually seen on the functional groups of the alcohols and the ketones, and it's between the oxygen and the carbon. So if we remember, oxygen's electronegativity is 3.5, carbon's electronegativity is 2.5, so that gives us an electronegativity difference of 1, meaning that we have polar bonds going on here, and we actually have dipole-dipole. So I will write that actually on this ketone over here. And for the sake of time, again, I'm writing it here, but any carbon to oxygen bonding is where you'll see these dipole forces. So the ketones, the alcohols, that's where you'll see those, as well as actually the carbon to fluorine, because fluorine's electronegativity is 4 and carbon's electronegativity is 2.5. So we also have dipole here. The third intermolecular bonding force that we see is present between the carbon to carbon bonding, which we see given the skeletal structure there is a lot of, and the carbon to hydrogen bonding. Given that these bonds are nonpolar, the electronegativity difference for carbon to carbon is 0, and for carbon to hydrogen it's 0.4. We just have dispersion forces. So I'll write that here. And again, I'm just writing it once, but it is present on any carbon to carbon and carbon to hydrogen bonding. So given that we have hydrogen bonding and dipole-dipole forces at play here, it's probably fair to assume that dexamethasone has a fairly high melting point, which it turns out to be so. The melting point of dexamethasone is anywhere from 262 to 264 degrees Celsius, which makes sense given that we do have strong hydrogen bonding and dipole-dipole, and so in order to break these forces, we're going to need more energy or more heat. So, moving on to the acidity and basicity of the compound. When we look at the overall structure of dexamethasone, we do see that we have functional groups in the molecule as identified before. We've got ketones, alkenes, and alcohols. However, we do not have carboxylic acid or amines. So off the bat, this tells me that dexamethasone is not acidic and not basic. It's actually neither. So it's probably good that dexamethasone is neither acidic nor basic, given its common uses and its administration to patients. So dexamethasone is used, it's actually a corticosteroid that is used to treat inflammation, redness, pain, and swelling. So I'm going to put it up here. some common uses of dexamethasone, because there are a lot of cases of inflammation. It's present in a lot of different issues. So some common uses for dexamethasone, especially within physical therapy, are for arthritis, bursitis, and tendonitis. And one interesting fact is dexamethasone is actually used in some cancer cases to help reduce tumor swelling. So one of the most common administrations of dexamethasone is through a process called iontophoresis, or ionto for short. I had briefly discussed that method in Molecular Diary 1, but I'll go into a little more detail now. So iontophoresis is actually a patch that has dexamethasone on it, and that patch is placed on the skin of the patient, and then there's an iontophoresis machine that sends electrical currents through the patch, and these electrical currents actually open up the microscopic pores on the skin of the patient, and this allows for the dexamethasone to enter through the skin and to go into the tissues and to help reduce swelling and inflammation of that patient's tissues on the targeted area. So that is my third Molecular Diary entry on dexamethasone. Thank you for watching and have a great day.
I don't know why it won't stop.